and today is a day 6 session, right? So day 6 session, and what is the agenda for day 6 actually? It's a very important day today because we will be covering, some of the important stuffs in the Docker itself. Okay, like for example, we will be covering about the Docker file, and we'll try to finish the Docker file by today. I think it's not possible to complete it. We will continue the Docker file and we will start with the Docker Compose. So these are the main important topics, sir, in the Docker section actually. So you have a Docker file, you have a Docker Compose. So if we are taking a class on Saturday, that is today, tomorrow, and day after tomorrow, that is Monday. So we'll be able to complete these things. If time permits, we will start with Docker networking. So we'll see how the thing goes, because for the Docker networking itself, I may need a one session, like 1.5 hour class or 2 hours class. So we will see it, because networking might go up to next week also. Next week Saturday also it might go. So Docker file, Docker Compose, these are the two important things. I think we even missed about the how you own your own private registry, right? I think we missed that. We will continue with that itself now. Actually, once we complete this topic, then we'll go to the Docker file. So, okay. So this is for the day 6 agenda actually. Day 6 as well as the day 7 tomorrow. Okay. We'll not be able to complete today itself everything. So this would be for this week, 3 days of class, day 6, days 7 and day 8 class. So before that, okay, let me launch the AWS. So go to the console. So
Rajesh, your voice is little low today. I don't know, means volume something or.
no, it's a full. Now, how about now?
Yeah, for me it is okay.
It is
Okay.
fine, Rajat.
Yeah.
Sure. Yeah, hold a second. Yeah, how, what about now? How? Is it clear now?
Yeah, it's okay.
Yeah. Yeah, okay. So let me log into my AWS. R6 CB, right? So let me log in. I think already I have an EC2 instance which I created. I think I stopped it at the last time. I think it's in stop state. Let me start it. Okay. So it will take some time. Eventually it will come up in 30 seconds or so. Okay. It's not coming out. Right. Mm-hmm. There it is. Supposed to come up. Sometime because of some network latency, something like that. The server will not come up very fast. We expect it to come by minimum 20 to 30 seconds. So now it has come. So let me connect it. It is coming running straight now. Let me connect. And you know that you need to copy this. So go to the folder where we have a PEM file, right? So I kept my PEM file under here, downloads. So let me open the git bash. Okay. And paste it. So okay, I have logged into the EC2 machine. So let me switch to the super user. Okay, let me increase the font. So now we are able to see now. So I have switched to the superuser. So let me check if I have a Docker. So when I execute Docker info, it means that Docker is already installed. Fine. So Docker we have. Now, what we will try to cover now, like how to create a node private repository, right? Like if you remember in couple of session backs, right, we had explained about that we have a Docker host. This is your Docker host, right? This is your Docker machine or Docker host where you install the Docker. Now, what is happening that whenever a Docker host, suppose you do a Docker pull nginx. So what will happen? Basically, what happens like your Docker host will check whether in the local cache if this image is there or not. So there is no image with this name. What the Docker will do? Docker will try to connect to your public repository, which is nothing but your hub.docker.com, right? You know this. So basically, what happened that your Docker host will try to connect to this, okay, and it will try to pull the image, whatever the official image is there here, right? The nginx image. That the Docker host will try to do a pull operation. It will pull it and then it will keep under its own local cache. That's how it happens actually. And this is the public repository, you know, right? This is the public repository. This is a public repository. But basically, what is happening is that in the industries, in the companies where whenever you want to keep your own image, right? Like you will not be, you will not be using a public repository, hub.docker.com. Though, as I said earlier, like it supports both public as well as private. But still, what happened? Many of the companies, right? What they will do, they will try to create their own private repository. Like for example, here I will create one more server like this, same like Docker host itself. So now what is happening under the same machine, Docker host? What I will do, I will try to set up a private repository here, like here, private repository or private registry. Okay, so you need to little bit configure to make your whole machine as a private repository, and this is like a private repository registry where it is like a local registry. So you can do whenever you create an image, you create an image. So after you create an image, you can actually push that image to your private repository. Push it. Later, whenever you want it, you can pull it. Similarly, this is a host machine. Suppose assume that there's one more machine or somebody who's sitting outside. He want to access this actually. Even he can also access it. So basically what happened that he has to provide the IP address of this host machine. So whatever you have an IP address right here, the IP address, whatever the unique IP address you have, right? That IP address has to be assigned. So using the HTTP protocol, what happened, the other machine, right? He can access this private registry. You need to do some settings to make sure that the other computer, which is outside your network, can even access the private registry, so that even he can also do a pull or push operation of the images into this registry or into this local repository. So in this way, what is happening? Really in the company, what happened, right? They will create one Docker host machine, and in the Docker host, what happened? They will install one private registry. Later, what happened, right? Across the organization, like wherever you have a branches or wherever you have a system, you can just connect it and you can do all the pull and operations. So here in this case, what is happening that we are not at all using a Docker hub, right? We are not at all using a Docker hub. So here, why we are doing that? Because like one is that actually you will make your image very secure, right? Nobody can access your images and all, because you might be building the Docker files or you might be creating a Dockers for your customer, right? For the application, for your customer's requirement, you might be building it. So you don't want to make it as a public, you want to make it as a highly secure. And secondly, what is happening that, it will be very faster. Why? Because, like you will be in your own local network, right? So pull and push will be very faster actually. Instead of here also in hub.docker.com also you can purchase the private repository. From private repository, here also you can purchase it. There's no issue in that. But what is happening that people don't want to take a risk. Many of the companies, hence they will do it like this. So to do this, actually, what we have to do, the basic requirement is that actually you need to install a registry a container here. It means that whenever I want to make my host machine as a private registry. Here, what is happening that you have to just have a registry image, or the registry image container has to run. That is what only is requirement. Okay. So now, how to do this? How we can play with this? So let's see how to do that. Now, going back to here in the server, if I check, let me check if I have any image, Docker image ls. So there is no image. Let me check if there is any container running. Nothing. Even not even a container is running. So let me do one thing. Let me pull some images, sir. Docker image pull. What is the image you can pull? You can, or else let me pull Nginx. Okay. So I'm trying to pull it. Let me pull a few more images. Docker image pull Nginx. What else? Docker pull Ubuntu. We will try to pull it. So here we are doing this for the first time from our main repository, from hub.docker.com. We are pulling it, and also I need to pull it Docker pull image registry. This is what I was saying. So you need to have this registry container to be running in your system. Docker image pull REGISTRY. Correct? No. Docker, I think it's wrong. Docker image pull registry. Docker image pull registry, right? So this is what it is. When I do a Docker image ls, you could see that I have to couple of like images which is already there in my local machine, and this is what it is. Now I want to run this image as a container. So how to do that? So I have to use a Docker container run. I'll do one thing. I'll run in a background. I think it's interactive. I'll do with a D, means detached mode. I'll run in the background. Here, what is happening that always the registry, right? It will always run in the. It always run on the port number 5000. Okay. So what I will do, I'll say -p. I will give 5000, and this is my local, host machine's port number I'm assigning, and this is my the container where the container, the register container will be running there. That's a port number. -fn name. What I'll do, something like simple registry, and specify the image name, registry. So if you run it, now you could see that Docker container ls. Now you could see that actually that your container is running. Clear? So it is using the port number 5000. So to access the container outside, you have to hit to this port number. Then you will be able to do it. Now what I will do, right now this is a simple registry which is running. I don't have any image actually inside, so that I will not be able to show if there is any image inside. It's basically just now I restarted it, so I know that there is no images, right? Now what is happening that suppose that tomorrow later I will push some images into this registry. So what I will do, like I need to do a command line browsing actually. To have a command line browsing, what you have to do, you have to install the elinks actually. Elinks is a package actually. So yum install elinks -y. Now if you install the elinks, right, see, you can see that the elinks package has been installed. Okay, now if I execute a command elinks, you could see that it is showing me some kind of a command line browser. Here in the command line itself, I can browse some website or something. Now whenever you are trying to access the command line, right, whenever you are trying to access the command line, basically you know that my machine is a local host. If I execute the fconfig command, you could see that I'm having a loopback address also, which is nothing but my own local machine's IP address. So I'm using this one actually. So you can just see elinks. I run it. Here in the URL, I will give, you can note it down this one, sir, 1001. Okay. You have to give the port number, I mean, where the registry is running. We know that it is using the port number 5000 /v2 version 2 / catalog, like that. So what is it? So after installing the elinks package, is yum links. Why? You need to execute the command links. So links package. It is what is it? It is a what is it, sir? It is a command line browser, right? Command line command line browser. That's what you have to install this package. So you need to execute the command line. Once you install it, what you have to give in the URL 127.0.0.1 colon 5000 support slash v2 version 2 underscore. So this is what you have to do. So once you give it and once you say enter, now it's open. So nothing is there. There is no repository. That I'm not able to say any image because obviously there is no image as of now, right? So I don't think I'll come out. So basically I have come out now. Now what I will do, right? Now I want to push it somewhere. Assume that I am having Docker imageless. Now if you see that I am having some images like we have Nginx and Ubuntu. Suppose if I want to push this Nginx itself into my own local registry, how to do that? First, let me do a tagging actually. I need to create a tag. As you know, in the last session also we have seen Docker image. What is it? You have to use a tag. And what is the image? The Nginx. Now here, what is the name you have to give? I have to give here 127.0.0.1 colon 5000. And then you basically are giving an image to this tag actually. And this is my local IP address, right? Loopback address with the port number I'm giving. I'm just giving Nginx. Now you could see that a new image has been created with the name 127.0.0.1 Nginx. So now what we will do, we will say Docker image push and specifies image name. Now you could see it is pushing. Where it is pushing, you could see it is pushing in your local machine itself, wherever the registry container is running. See, it is pushing it. Now, how to verify whether it is being your image Nginx is there in local? Same thing, you have to execute the elinks command. Elinks, I'm browsing it, same thing. 0.0.1 colon 5000 slash v2 version 2 underscore. This is by default, guys. You have to give the same name. Okay, open it. Now you could see that your Nginx is there. Same thing, 127.0.0.1 colon 5000 is the port number slash Ubuntu. So you are creating a new image now, right? Docker image, you have to do the tag, next the tag here, Docker image, get the tag, get the, now it's a Docker image ls. Same thing, now you are having a new image with the Ubuntu with the new image. Now you know that Docker image push space. So you could see that it is pushing it. Now, okay, so it is already pushed. You can execute the elinks again. Do the same thing. What is it? v2 slash underscore catalog. This you have to remember, guys. That's what I'm going to keep saying it. Now you could see that you are having two images, right? Nginx and Ubuntu, it is there in my local. Now the thing is that actually here I am using a loopback address of my own local host, right? Local host. See, if you ping to 127.0.0.1, you are actually pinging to your own machine itself. Actually, even you can ping like this, or even you can ping a local host. If you either ping to the IP address or localhost is nothing but what? It is nothing but your 127.0.0.1 itself. Now what is happening that you will say, Rajesh, if I execute the ifconfig command, and you could see this is my instance. This is my instance, correct, right? This is my IP address. This is my local 80 IP address. Why don't I tag with this IP address? Okay, let me do one thing. Let me one tag also for that also. So let me do one thing. Let me do a Docker pull Docker image pull Docker image pull. Let me pull CentOS. So I'm pulling the CentOS image. Okay. So if I execute Docker image ls, now you could see that I have a CentOS machine. So let me create one more tag actually, Docker image tag CentOS. Same thing. What I will give an IP address of my machine again. This is IP address. So let me check this one. So I'll give this as a tag and :5000, correct, and give the image name. So now I have created one more new image of image ls. You can see that I have one more image of CentOS. Let me try to push it. Let us see what will happen. Push, specify this. Whether it will push or not, we'll see it. Now, if you see it, if you're trying to push with your local IP address or ET0, it is saying HTTP server gave HTTPS response to HTTPS client. It means that actually basically what is happening that it is trying to assume that whatever the IP address you are given, it's a local IP address, but you cannot access without HTTPS. Without a HTTPS, you cannot access it. With just HTTP, it will not work. You have to have you should have a secure HTTPS to do the image push of this image, of the CentOS image. So it is not possible. It means that actually you need to have some kind of a certificate has to be installed. You need to configure such a way that actually it has to support the HTTPS even for this IP address also. See, locally I'm doing with 127.0.0, I'm able to do it. Here what is happening that here it is not really looking for the HTTPS. But when I'm using an IP address for the image, right? Because ET0 is my own local machine IP address. Even though I'm building an image with this IP address, still it is expecting me to do a HTTPS, means you require an HTTPS protocol. It means that you need to have a certificate installed and everything. Now what is happening that just to conclude this session, or just to tell that, okay, man, Rajesh, even though I have this, I don't want to, I want to just skip this, man. I want to do an HTTP only, not HTTP. I want to skip the, like secure part. So how I have to do means basically what you have to do that you have to create one JSON file actually. So how to create a JSON file? I'll say vi what is the JSON file? DAEM1 daemon dot JSON file. You have to create one JSON file. This is the method you have to do. Okay, JSON. Here what is happening is that actually here you have to create. Maybe you might know or not. Some of you might know. Some of you might not know the syntax. Later we will discuss. Secure hyphen what is it? Registries, right? Registries. The IP address. Let me copy it. So I have to give my IP address here. Okay, I have to give :5000. That's the port number which is running, and just close it. That's all. This is the only one line insecure registries you have to add, and this is the your local ETH0 IP address with :5000 is the port number, and you have to just save this one. Now what you have to do that you need to do you need to copy this daemon file under etc docker. To copy this. This is the second step. After that, what is happening? You have to restart the Docker systemctl. Okay, restart Docker. Now, when you restart the Docker, what will happen? Suppose already a lot of Docker containers are running. Already a lot of Docker containers are running. All the Docker containers will get stopped. You will see that my registry was running, right? So now what happened? As soon as you restart the Docker service, what is happening that whatever the images are there or containers which are running in your system, right, all those will be stopped unless and until you have a restart policy actually. So what is restart policy? We will see it. So in Docker, we have something called as restart policy. So what it means actually basically, like even you restart the Docker service, okay, by using the systemctl restart Docker. So what happens is that all the running container will also get restarted. If you don't have a policy assigned to a particular container for the restart policy, that container will go to a stop state or exit state. You could see that now, if I exit ls-a, now you could see that my registry, right, it has been stopped, now it has been exited. It has been excited, right? It has been exited about a minute. So let me do one thing, let me start this actually. Docker container start and specify my name itself, simple underscore. So now if I do a Docker container ls, now you could see that I have restarted or I have started my I have started my registry. Now what will happen, right? I have an image, the Docker image ls. Now you could see that if I'm able to push it or not. Let us see. Docker push, Docker image push, and specify this image. See, now we are able to push. See, it means that you are suppressing the HTTPS. Only with HTTP you are able to do. How we are able to do? We have created this daemon.json, right? We created daemon.json. So let this happen. So they might ask in interview about this, but I could see rarely people don't ask these things, but it is just good that you have knowledge of these things. So this is the command actually. So if you want to see the content of the JSON, you can see the video again, but just I'm saying that you need to add this. This is the content. So just after this, you have to copy it and you have to restart it. And once you restart it, you could see that the running control already come down or it is go to the excited state. Again, you have to start it and then you have to do a push. That's also. When you can like this. Okay. Now again you can go to your relinks. You know now very well now. You have understood 127.0. Let us see what to do. I think I have to do data pages. You have all the images, CentOS and all the images. So now what is happening that now you are doing it locally, as I said. Now what is happening that suppose in other machine somebody want to pull this CentOS or Nginx or Ubuntu, whatever you have in it, right? So you need to install a certificates and all. So that I have already given a step, but I will probably take in a next session actually. See, I think I already shared that thing, those steps to you guys actually. Last time only I told about this. Right, I think somewhere I have written it. I showed you also in the last session. Where is it? Okay, somewhere I've kept it. Okay, I will anyhow. I will do it again. Actually, those things will do it again. Okay. So till here, do you have any doubts, sir? Doubts? Docker container. Let me. I'm just stopping or I'm just filling it. Docker in a container. ls everything is there. Docker image, you have Docker, RMI, CentOS, Docker, image, connect into Nginx. I'm just trying to remove all these images. I don't need it. Then Docker image ls. Let us see if they have any image. Yeah. I hope you got it right. Guys, any doubts you have? So I'm just trying to remove all the images. Docker image ls. Yeah, no. Something is there. Yes, sir. Any doubts you have till here? Because we will start on with the Docker file actually. Okay, fine. Now comes a very interesting thing to learn is a Docker file actually, and we have to learn because the ultimate purpose of our working in a Docker is nothing but you have to create a customized image actually. Okay, you have to create a customized image. So what is the necessity of learning a Dockerfile? Why we have to learn a Dockerfile? Basically, like whenever like whenever a developer develops the application, whenever the developers develop applications, what he'll do, right? Basically, he will mention the application, the dependency of those applications. Suppose those application might expect some kind of a package to be installed before the application runs, right? Some package to be installed. So suppose if, for example, some web application is there, you say that Rajesh, I want to like make my application to run under the Tomcat server, right? Apache Tomcat. So the prerequisite for your application is that you need to have first Tomcat server to be running. Then only your application will be hosted or it can get started, right? After that, what is happening that there might be some dependency even with some package also. So it means that you need to install some package and all. So before like maybe there's a requirement actually your application want to first build it out, and then like once the build is completed, whatever the var jar file er file you get, right, you will be deploying under the Tomcat server. So a lot of dependencies are there, and also like you might be even passing some environment variable for your application during the application start, right? So whenever you are running any jar or er file, right, what happened that you need to pass a lot of environment. So for that you have to pass some critical like environment variables and all, right? So whenever an application requires, right, like it requires a lot of dependencies or it requires some prerequisites are always there for every application. So what you have to do that the developer, what he will do, he will develop the application finally as a microservice. And what happened that he want to like he want to deploy this application which he has developed in a running container. It means that basically he want to make his application running in a container, right? Now what is happening is that for that, what the developer will do, he will try to, and also like your application might be using some port number, so you need to have the port to be exposed so that if any client want to access the application, he can access with the application by providing, by hitting that IP address of that machine or the DNS name with the port number, right? So those are all things are there. Now what happens that whenever he want to build that application under the Docker container, he said that I want to finally build my application under the Docker container. It means that you want to run that application in Docker container. So you can actually only with the help of writing a Docker file. Okay. Now, what is a Docker file basically? A Docker file is nothing but it is all collection of the Docker commands. It's all collection of Docker commands. Whatever the Docker commands which we are using or which we know, although we are using those Docker commands in a Docker file to make it sure that my application runs. But You need to understand many more Docker commands to able to write comfortably Dockerfile, as well as what is happening that you need to even know that how you can customize your Docker container. See, whenever a developer, right, he will, if he provides the information to a DevOps engineer that, okay, man, you have to write a Docker file so that you are customizing my image to run under the Docker container. For that, these are the prerequisites. For these are the environment variable we have to pass for running, and this is the kind of a port number which I'm exposing so that you can access that application. He will give all kind of a requirement. So being a DevOps engineer and and having a knowledge on Docker, you should able to write a Docker file by your own. So how you know how to write a Docker file, we will see now. But the ultimate requirement for the Docker file is that actually you are trying to write a customized image. You are trying to write a Docker file is basically used for customizing the image. That means that you know how to write a Docker file. That means that you know already you know the Docker commands, what are the Docker commands we're using. Plus, you need to even know, you should have a knowledge on how I can customize or how I customize the Docker image, how you can customize the Docker size itself actually. It means that always, many times what happens, right? The client have some requirements actually. Suppose, for example, if client might say, listen, you need to you need to dockerize, dockerize the application by writing Docker file. But my requirement is that in your Docker file or in your Dockerize, I should only allocate 10 IP addresses, not more than that. Plus, the IP address should not fall under 172 range IP address. Like that. It depends, right? The customer might have a lot of requirements. Based on that, also he might tell you. So now what is happening that you should have an idea. Whenever you're writing a Docker file, you have to have an idea. Okay, man, how I should see. Whenever you're creating a Docker, you will say that Rajesh, how many IP addresses it can use? It can use n number of IP addresses. You can even use 255 IP addresses. It can use 255 to 255. Lot of IP address it can use. There is no restriction for making use of IP address because you're using a private IP address. But customer might come and say that no, my Docker file should only use only 10 IP address. So there is a way you have to restrict for enabling only to make use of IP address. As well as he's saying that actually my IP address should not fall under this 172. So in that way, what is up that basically you try to give some kind of a networking. You are giving a network. You're saying that okay, man, whenever the Docker is using, you should not use 172 range, it should use 192 range. Like that and all, you can enable it. So there are many things are there you need to understand while writing a Docker file. So it's all depend upon the developers, what kind of requirement is has, and he will give all kind of inputs to you. Taking that inputs, you need to start writing a Docker file. So while you're writing a Docker file, you need to customize a Docker file based on requirement, as well as there is always a requirement is actually your Docker, whatever the Docker image which is created after running a Docker file, your image should be a very, very small image. It should consume very less disk space, very less memory it should consume. See, suppose like you write a Docker file where you might have used a lot of steps to run an application, but your Docker image is 250 MB. The same application, for implementing the same application in the Docker, somebody else has written just in a span of 150 MB. Right, 150 MB, he has written an image where the image is only consuming 150 MB. Then your Docker image, what are the Docker file which you have written, that will be asked compared to this. Even though both are doing the same thing, but your Docker image is consuming more memory than the other person. So that's what, whenever you're writing a Docker file, that is also one of the things which has been taken care that wherever possible, how you can reduce the size of the Docker image. So that is the importance. And one more thing, what is happening, right? Why Docker writing a Docker file is tricky, or like why it is important, what are the things you know, because writing a Docker file is very tedious task. It is not simple. We will say that it is a simple task, it's a very simple, but actually speaking, right, you need to have a lot of knowledge in writing a Docker file. Okay, you need to have a lot of knowledge. What is it? I will explain you later why it is required so much knowledge. Okay, so there is a requirement that you need to have some good knowledge while writing a Docker file. Initially, you might be in slow in learning. Once you start working in writing more and more Docker file, you'll get a lot of ideas. You'll Google it out also. You will get many of the articles, good articles, which they have said, like how to use, how you can reduce a Docker file, how you can use a very light base image. Many things you will understand it later. That's what it is very important you to learn Dockerfile. And even in many of the previous session, I've been keep telling that most of the time in the interview they'll ask only these questions: Dockerfile, Docker Compose, and a few stuffs in networking like that. These are things which are mostly asked. Okay, so that's how. Okay, now what we will do now is that actually we will see now. Now, see if you pull any image, suppose if I say, if I do a Docker image pull CentOS, if I do it right, you know that okay, my Docker host is actually connected to my hub.docker.com and it is trying to pull the CentOS image, right? And it is pulling the latest CentOS image because I'm not giving a tag over here. Hence, it is actually pulling me the latest image, whatever. Hold a second, guys. Okay, guys, sorry. So sorry, where I was. Yeah, I was into, yeah. So here, what is happening that you're pulling an image actually, sir. Now you might ask me a question actually. What is this image actually? These images are nothing but it's they are nothing but we call it layers, sir, actually layers. And again, these layers are nothing but it's a directory, sir. Layers in the directory. To explain you in a better way, let me do one thing. Let me again. Let me open one more instance here. Go to the download. So it is very interesting, sir. We have to know all these things very, like the basic fundamentals and all. We should know it very clearly. So always, all the images are nothing but layers. It is not the combination of the layers, or it could be a single layer. It could be a combination of many layers and all, right. But again, what is a layer? It's nothing but it's a simple directory. It's like a file system directory, like that. Now, if you see here, now I have pulled the CentOS image. Fine. Let me do one thing. Let me remove this image. Now, what is happening now, sir? Like for the home directory for your Docker is /var lib /var lib Docker. This is the home directory, sir. If anyone asks you what is the home directory of a Docker, I remember you have to say /var lib Docker. Similarly, what is the home directory for a Jenkins home directory for Jenkins? You have to say /var lib Jenkins. If you install the Jenkins right in your system, you would get this directory /var under lib. You will get Jenkins. Okay, but here we are discussing about Docker. So if you say ls, now you could see that actually there are many directories are there. And in the last class we were discussing about the volume. I said that the volumes will get whatever the volumes we are creating, the entry will be made here. Similarly, whenever you are pulling any image, the images will be resided in the overlay2 directory, right? If I go to the overlay to directory, so here nothing is there. Okay, nothing is there as of now. Now you would see what I will do. I don't think I'll say run the watch command. Watch. I will run for every 1 second. I'll do it. See, I'm watching it here. Now you see what I'm doing here. Okay, I'm watching here. I'll go to the other one, other terminal. I'll say Docker full image. See, I'm running, I'm pulling the image. You could see that actually it is trying to connect to my hub.com. Under that library CentOS, it is pulling it and it is extracting it. And here you could see that it has already pulled an image. Now, if you come here, you could see that now nothing was there. Now a new image has been created. It means that an entry has been made here, right? So you could see here, if I go to the /var, /var lib docker, and you could see, you go to the overlay, and you could see that actually this is the new entry there. It is basically a directory. So this is the image actually, image name. If you do a cd to the 50 entry and ls, now if you go to the diff actually, this is actually a content of your CentOS. This is the content of your CentOS. CentOS is not, it's a small image of operating system, right? This is the content of CentOS. Now you could see that actually when I pull the image, an entry has been made under the overlay directory /cd/var lib docker. Here what is going? I'm just I'm by using the watch command, right? I'm just watching it. Suppose I will do docker image rm-f CentOS. See, you are untagging, you are deleting it. See, the entry also has been formed. So when you try to pull it, what is happening? When you try to pull the CentOS, you could see that image is getting created. Right? When an image is getting created, when I'm trying to remove it, it is getting deleted. See, it is getting here, sir. Here. Now, what is happening that? Let me do one thing. Let me pull some other image just to make sure that we are understanding it better way. Let me to pull a MySQL. So it means that here what happened that when I pulled the CentOS, only one image was pulled, right? But when I am pulling the MySQL, it is not one image, sir. There are many images are there. 1, 2, 3, 4, 5, 6, 7, 8. There are more than 7, 8 images are there which have been pulled. So what are these images? These images are nothing but a layer, or layer is nothing but a directory. Now you could go to the other terminal. You could see, so many images are getting pulled. It means that basically what is happening, sir? What is happening that you are actually what is happened when I did a pull of MySQL, there were many layers got created like this: layer 1, layer 2, layer 3, layer 4, layer 5, whatever. N number of layers got created. Okay, this layers got created. So all these layers, as I said, are nothing but the directories actually. So now what is happening, right? Docker basically it follows union file system. Okay, union file system. You might have your own, read about union. What is a union, right? Like for example, in the school days, you have A, comma B, union of C, comma D. What is the value? It is A, comma B, comma C, comma D, right? So it means that actually union is nothing but combinations. Actually, it's combinations. It means that actually, if a MySQL having 5 layers, actually, this 5 layers is nothing it's a union of all these layers put together. You make it as a MySQL as a one image. So MySQL is not one single image; it's a combination of multiple images, and each image is a directory. Each image is a directory, and how actually it works based on the union file system, and for the union file system, right? To support the union file system, there is a file system driver known as the overlay to driver. Overlay to file system driver. So for every different type of file system, right, you need a kind of a driver to communicate with it. Here, what is happening that the MySQL might be having 5 or 10 images. That doesn't matter. I'm just saying it is nothing but it's a combination of all these different layers are 1, 2, 3, 4, 5, 6, 7, whatever images are there. So to make it as a single image, okay, to make it a single, to make it as a union, actually, it uses the overlay to driver. It means that your Docker uses the overlay to driver to communicate with the MySQL database. So we are not really discussing those things in detail. You will, if you go to the official document of Docker overlay to file system, you will get to know many things actually. So there are a lot of drivers are there, but the Docker majorly uses the overlay to file system. It means that all these layers are nothing but it's a all these layers are there, but it is actually working as a single image with the help of an overlay to file system. Till here it's correct. Is it fine, sir? Any doubts you have? So now what is happening that, but what is the use or why we are actually, what is an advantage of having a union file system? Basically? See here, for example, if I pulled the Docker image, I pulled the MySQL image here, right? You have pulled it. Now assume that actually I will say Docker image pull nginx. Just to watch what is happening. It's saying that while pulling an Nginx image, it has pulled many images. But what it is saying that actually it requires one image actually, but already this image exists. It means that while MySQL is getting pulled, one of the image also got pulled along with that. So this image, we will see what is this image content. But even Nginx also uses this image. So it is not pulling it again. It sees that in the cache, already there is some image already exists. It will just make use of this image. And which are the other images which is not in the cache, it will try to pull everything. So in that way, what is happening that the Docker is actually saving your storage. Because it's a union file system, if that particular layer, it is being used by multiple different images, it is not like every time it will pull the same image again and again. If already this image exists, it will just reuse that image. So here in this case, you could see that Nginx, let's say that is already there. Now you could see that actually Nginx is actually depend upon this image. Now, but this image is also used by the MySQL. So like that, there are many images are there which has been commonly used by the different images. So this is what the concept of the union file system or overlay to file system driver. Okay, sir.
Yeah, Rajesh, Rajesh, can you go in overlay file system that directory in?
Yeah.
Okay.
Okay. Now, okay. See, now what I would say, right? Like, see, now suppose like for assume that actually, okay, I'll do an example. I'll take an example actually. Okay, let me remove all the images. Let me remove all the images to make you better understand. Remove it. Docker image alerts. Let me, sorry, Docker image alerts. Let me see if there is any container running. Docker container alerts. Okay. It is running. Now I'll do one thing. I think the other terminal, touching it. Yeah, still there. Now here, what is happening is that now we could see that actually, if I do a Docker image pull, I'll use the same old one, CentOS actually. I'm putting the CentOS image. So you could see that once you pull the image, you could see that the image entry has been made here. Okay. Now, what is this image basically? So we will say that Rajesh, this is nothing but your image, right? This is nothing but your CentOS image. Sorry, the CentOS image. But what is it basically? It is nothing but it is a read-only image. That means that see this is the ready-made image which is given by somebody, right? And they have placed in the hub.docker.com or a CentOS community itself. They have given it. They'll only give a read-only image, sir. Means you cannot edit it actually. Later, what is happening that you have pulled that image now. Now what you're doing, right? Let me run the Docker container. Docker run hyphen it d. Let me run in the background. Let me make it as CentOS and what is the image name? CentOS. So here, what is happening that I'm running the container now. Docker container ls. Now you could see that my CentOS is running. But if you see here, now you could see that apart from this image, right? You could see that two more images have been created, right, in the overlay. Can you see? What is it actually? Now, what you are trying to do here, when you are trying to run a container here like this, when you're trying to run a container, sorry, see, this is the read-only image. But what happening? I'm using some command Docker container run like that. You are trying to create one container. What is this? This is nothing but your CentOS running container. But this CentOS running container, sir, this has created in turn two images. It has created two images. One is a, I'm sorry, I'll write it here. One is a read mode image, and other is a write mode. Please understand this, sir. Write mode. That's what you could see these two entries here. Right. Now what is happening is that actually that here once you're it means that actually through your read-only image you have made a container by making that image to run as a container. But in turn, what is happening, right? It has actually created two more images. That's what you could see in the overlay. There are two images more, which is apart from that, the base image, which is number the image. You've seen two more images running. Now what is happening is that you come here. Now you want to get inside the Docker. How will you do it? Docker. What you will do? You'll go to the Docker container hyphen exe hyphen it exec hyphen it sorry exec hyphen it interactive. What is the container ID? See, now you are inside a container. Now you consider I can even create abg.txt. See, so what you are doing here in your image, now you could see that already a running container there is there. You have created a new file. That's abg.txt. So this is your running container now. It has all the data. Now assume that I am just Docker container Docker container. So it is running. If I kill it, what happens? Docker container rmf CentOS. See, I'm killing it. When you're killing it, you are actually destroying this whole image. This is a running image, but whatever the running inside is there, right? You have did a lot of changes into that running image. Mean that I have created a file, I have did anything, I even set up a Apache server, I even hosted my application. Everything is up and running. Once this get killed, right? Once you get stopped or kill it, even all the data you're losing actually. Again, you're back. Here you could see that if as soon as I killed it, you could see that again those two images which read only and write, right? Read only mode and write mode. These two images, whatever they are, right? That has gone now. You could see here, that is no more. Right? Again, you do a create. Again, same stuff. You create it. Again, you run a container. What is it? Docker container run hyphen itd hyphen a name and toss. See, again you could see that again this read and write layer of getting. Now it means that actually as and when you run the container separate, two more layers will always get created. Whatever the operation which you are doing here, that would be running here itself. But what is happening is that actually, if you want to save this, whatever the things, whatever you are writing into the running image, you want to save it means, in the last class we had learned about something as a commit. Actually, you have to commit it. Actually, if you commit it, you will get one more new layer, one more new image. You will get one more new image. This image has the everything, sir. It has the CentOS, plus it has the file what you have created. Everything would be there in this. So, but this is not recommendable. This is not recommendable, right? So, what is happening? So that's see, that is what for me, for you to have this complete customizes image, everything by own. It means that I need to run my image n number of times, but my image should also have the changes whatever I have did or whatever I need, whatever changes I have did into my image, that should always persist. It should be there. Means that's the reason you write a Dockerfile. This is the one of the reason you have to tell. That's the reason we need to write it out. In the Dockerfile, we mention everything. I need this file. I need to host my application. I need to install the Tomcat. After installing Tomcat, I have to host my application with all this parameter, everything. That is what the reason you need to learn how to write a Dockerfile. So till here, is it clear, sir? Right. So this is very important, sir. You need to learn or you need to remember all these things because this will this will help you to understand in a better way in the future, right? How exactly Dockerfile works, everything, and what is a Docker Compose, everything. This will definitely help you to understand more on this. Okay. Now, for example, here, okay. So let me Docker container rm-f CentOS, I'll remove it. Okay, Docker image ls, I will remove the Docker image. Docker image rm-f CentOS. So I'm removing even the image also, sir. So nothing is there. Now you could see that. Now this is also gone, right? As soon as I remove the image, even the under the overlay, even those things are gone. See, I'm under the overlay now. So I'm running a watch command to make sure that I'm using ls command onto this overlay every 1 second. Like this. That's what I'm just trying to monitor this whole directory. Okay. Now, if I do a Docker, what is it? Image pull HTTP. So when I'm doing HTTP, now you could see, sir, that you are actually pulling, basically Docker is actually pulling the whole HTTP image, but HTTP image is a combination of 1, 2, 3, 4, 5, 5 images, sir. It's a combination of 5 images. Now if you say Docker image ls, if you say Docker image ls, you could see that actually this is what your image name and this is the image ID. If I do a Docker image inspect and specify your image ID, now you could see that, sir. Can you make out here? These are not but the 5 images, right? So the HTTP is made up of these 5 images. Clear, sir? Now, if you see in the overlay, right, these are the 5 images 1, 2, 3, 4, 5 images. Now, if you go to this image, sir, I'll copy it. I'll do one thing here. Cat of /var Docker overlay 2 and specify image. /var Docker overlay 2. I should do ls, ls minus d. Okay, ls, this one. See, ls. 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 So these are the 5 layers of your HTTP, right? When you do this, now you could see that every layer has this some files. It has a diff directory, link, lower, work. Again, it has some other image has committed, link, lower, right, work, committed. This layer has a committed diff link. This image has a committed diff link, lower, work, lift. But you could see in all these 5 images, sir, okay, in all these 5 images, one image doesn't have a lower, which is that this is the image, right? See, this is the image, it doesn't have this. So what will happen, right? This image will be a lower image, sir, actually, like this. If you go to the diagram way, if you go in the diagram way like this, actually, right? If you layer 5, layer 4, layer 3, layer 2, layer. The layer 1 is the lowest layer, sir. And that lowest layer is nothing but this image, sir. This is the image, because it doesn't have it doesn't have that that lower this
Lower.
yeah. Now here what is happening, that you have a link actually, sir. See, it means that for every image there's a link actually. Let me do one thing, let me also have here link here. Here also we can have a link. You know that every has a link. You can even give a link name also, sir. Like suppose I give a link name as, okay, for this link, I'll give this link, or else I don't know how to draw it actually. Yeah. Okay, what is the link name I'll give? I'll give AB, or else I'll give from the lower here. Here I'll give, or else what to do, sir? I'll give the link 5, or not 5, something, sir. AB, AB, CD, EF, GH, and IJ, something like that, right? Now what's happening is, right, now what is the meaning of union means actually, now the layer 2, it has a combination of both layer 1 layer 2. That's what it has. It is the part IJ plus GH, sir. Similarly, layer 3 is nothing but it is a combination of layer 1, layer 2, and layer 3. That's what it is, a combination of EF plus GH plus IJ. Do you agree with me, sir? So layer 5 is nothing but it is a combination of all the lower 4 layers, sir, actually. It's a combination of all the 4 layers. That's what this is the link actually. It is basically having only one link actually. If you see this one, copy, paste it, and give a slash link actually. I'm just displaying the link. See, or else what I will do, I will use the cat command to, not ls, cat command. See here, what's happening, that is showing you the link actually, one link actually. Similarly, if you do a cat of this file, this image, I think, yeah, this, or else I do this one, this image, and I will do a slash link. Okay. So it is showing me that has this has two images. You can even go to this path. You can even go to that directly. Go to this D3. Let me see cat of link. It will show me the link actually. Basically, this link is there. Similarly, what is happening there? I come out, and if you go to this, so it means that basically it has all those links, links to the previous or links to the lower, like images or layers. It has all those things actually. So basically, it has the information about all the lower links or whatever the lower links we have, or next to the layers, right? Whatever that information be kept under the link actually. Diff, we know that the image, whatever the image content itself will be there in the diff. If you see it actually, you might not get to know, but these are the contents actually of this image. Actually. What is this image? We don't know. But as I said, like HTTP will be a combination of many of the layers actually. So all this is possible because of this union file system. Union file system. Okay, union file system.
So Rajesh bhai, after seeing that image ID, how we
Uh-huh.
can say that like third image is the combination of one, two, and three.
No, that's what here. What is happening here? Always we have to see the link actually. Uh, are we seeing any link or what we are seeing? At the time, okay.
We did
Link.
cat command. Okay.
We did the link. Link is a basically a file.
Cat link.
Link. It's an internal representation, sir. I mean, when we have to check what is it actually. Committed is a different thing. It's a basically link will have all this information. So what is it? Even I have to check it out actually. What is
Okay.
it?
Okay.
Yeah.
Something. Rajesh bhai, something which is coming with QG5. So after that, again, we have to
Mm.
go and we have to check that image ID or something. Then we
2G5.
get to,
Where is it? Can you tell me?
yeah. When you did cat link, so it is
Mm.
started from QG503, and after
Yeah,
that,
yeah. Uh-huh. Now,
so
suppose for example, here I am getting to some layer here. I will do a cat of link here. Yeah, it is showing me QG50, right? It's
yeah,
a content it is showing actually. What is QG50? QG50.
again do cat. No, it is not matching with that.
No, no,
Can
no.
you?
That's a file actually. Link is a file actually. Link is a file actually. If you say a file of link, you say it's an ASCII file actually. It's an ASCII text file. But if you
Yeah.
are seeing the content using cat, it is all if you're opening the VI link. This is the content actually. So basically, it has some because we don't know how internally union file system works, right? Maybe it might be keeping a link of with the help of some method. It is keeping the information about all this layer information. That link. Basically, if you understand this diagram, it is fine. Links
Yeah, yeah.
mean that it has some number actually. So in that way, that's how the union file system works.
Yeah. Thank you, Rajesh, bhai, for this explanation. Of course, this
Yeah.
info.
Okay. Now, okay. Yes. Okay. Now that's what you got to know from this diagram, right? Like why we have to basically learn the Docker file. Uh, like because like it will help us to create a customized image where we can run a customized image and whatever your requirements are there, right? That requirements will be there as part of your building a new image. When you have an image, even that image should have all kind of requirements whatever the customer has or whatever the application requires to run. You cannot like on fly you cannot make the changes in the running container, because tomorrow if the running container get failed or get killed, right, whatever changes which are running, right, under the right mode image, right, whatever the image running, even that will also get killed actually. So that's the reason always people prefer to go with the Docker file creation. Docker file, with the help of that, as you know now, that you can create a custom image. Okay. Now, what we will do, sir, we will do one thing. We will play with some we'll play with the Dockerfile today, a few steps, and tomorrow again we will continue with the Dockerfile with a lot of good examples and a lot of Dockerfile commands itself. And then once we complete the Dockerfile completely, then we will get into the Docker Compose. Okay. Now, whenever you write any Docker file, so what we will do, I think we're already running out of time. Like we have another 15 minutes, 20 minutes. So what we will do, don't think we will just play with the simple stuff. Docker, okay, so nothing I have now. Now, whenever you want to write a Docker file, sir, whenever you are writing a Docker file, the file name should always start with a capital D and other should be small. The file should always be with this name, okay, Docker file. So whenever you are creating a Docker file, always better that you always create a directory. So like if I do an mkdir, like something like my image or my web image. So get inside your my web image, and here you try to create a Docker file. Suppose I will create a Docker file like this, Docker file. Okay. Now, whenever you create a Docker file, sir, whenever you are creating Docker file, you need to build the image from any of the base image. Which without a base image, you cannot build an image, sir. You need to have a base image, right? Like for example, if you say that Rajesh, I have a requirement, man. I have a requirement that I need to install an Apache, and after installing Apache, I have my website or my web application. I need to host my web application into the Apache. Now you will tell Rajesh, okay, fine, you do it. Now what you will do, you will say, okay, Rajesh, and I want the Red Hat machine or CentOS machine. Red Hat in the Red Hat machine or in Red Hat Linux, I need to achieve all this stuff. I have to install the Apache. Apache there is not, but it is HTTP. You change HTTP, and then after that you need to. Okay. Now you will say that, okay, Raj, how you do that actually? You want to say that, Rajesh, I have to first initially buy a machine, and install Red Hat Linux, something like you install RHL 7 or RHL 8 machine, and then on top of that you will install the package yum install httpd-y, right? httpd-y. After you install it, what is happening that you will get inside the /var www.html. Under that you will place all your application, paste or copy the complete application under the www.html. And then what is happening that after that you will say service httpd start, or else you can use even systemctl start http. Like that you will start the service. Once you start the service, your application will be up and running, and you could see that if you hit the IP address of that server with providing the port number, you'll be able to access that application which is running your Apache server, right? This is what the requirement is, right? You are basically building an application, means you need to have a machine and everything. Similarly, I want to build an application. I want to build an application in a Docker, in a Dockerize. I want to build an application. But to build it, you need a some kind of base image, right? Like you need a machine, right? And where after having a machine, you should install the Red Hat Linux, right? You have to install the operating system, right? Similarly, like that, to Dockerize my application, I need some base image. Let it be any base image. Let it be CentOS or let it be Ubuntu. I need to have some kind of a base image, sir. To use the base image in the Docker file, what happens? The first line will always be a from instruction or from command. From, suppose I will say Ubuntu, I'll give some, even the version of 14.04. Okay. From this 14.04 Ubuntu version, I need to build my image. Means that for you to deploy any application, something, you need to first have an operating system. So how you will get it? Using the from. From will basically tell you that actually you are using some kind of a very base image. From here you are starting to implement your application. So from is an instruction, a Docker command we say. Okay, like that there are many others. Okay, so we will start with the from, and you could see that actually you are building an application from the base image. After it, now what is happening that from this base image, what I want to do, I want to install the packages. I want to install the package. I want to get into the directory. I want to start the service. I have to do many things actually. To deploy the application in your Ubuntu or in your RHEL, you have to use a command for run command. Run. Suppose here I'm using the Ubuntu, so I'll say apt get update -y and apt get install patch2. This I use. Same thing if I'm using a CentOS or Red Hat, if I'm writing a Dockerfile here, I'm writing a Dockerfile using CentOS. How I'll do? From CentOS colon whatever latest, or without that also due to the latest, run yum update -y, because I have to use the yum command in CentOS and apt in Ubuntu, and yum install httpd. Like that we'll be using in our, where is it, in our CentOS. You got the difference, sir? So here in Ubuntu, you need to install, whenever you want to configure the Apache, you have to install a package by name Apache 2. Whenever you want to install an Apache in CentOS, you have to use a package with the name of httpd. After that, you need to copy it, you need to get into this directory, you do blah, 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 everything. There are many commands. For example, you want to get into this path. So how to do that? You say work dir. This is a command, sir. Work dir /var /. You can do this way also. Some people what they'll do, no, they'll just run cd to /var. Both are same, sir. You might even see this also. Many times you can even see this also. Both are same. It means that you are actually running a command whenever you want to running some command into the image. Now you see that. Please try to understand that this is an image, sir. This is the image. What is it? It is only a read-only image. You cannot install and everything in a read-only image. You can only do installation and all whenever that image is running as a container. And when it's running as a container, you will get a write mode image and read mode image. It means that you need to run as a container, get inside the container, and then install all these things, run all these things. So what the Docker is so clever that it will run this image, sir. It means that when you are running this Docker file, it will run this image as a container. And then on inside the container, it will execute this command. Got it? That's what you are using run. And being in the same container, you're installing as well as you are actually getting into this path. And finally, you're doing many more further things. Like that, you are building a Docker file. Is it clear, sir? Any doubts, anything is going in your mind, just ask now itself. Anything. Like, for example, where is it? I'll open the notepad. Yeah, you can see it. Till here, you have any doubts, sir? Clear?
Okay.
Hmm?
Yes, sir.
All clear? All clear?
Yes, sir. Yes, sir.
Great. Lovely. Yeah. So let me do the same thing. Okay. My web image already created. I created a file known as Dockerfile. I think I already opened it. I think I've already opened it in other page. Yeah, here I already opened it. No problem. So I opened it. So I use a from image. What should I use, Ubuntu or should I use what is Ubuntu 10.04? Okay. I'll do one thing, sir. Let me do one thing. Okay, let me have the Docker file. So I have only one content, only one line. Okay. Okay. Now what will do one thing? Docker page ls nothing is there. I'll do one thing. Watch on Docker image ls. So I'm watching it. I'll come into this terminal. I'll not run the Docker, sir. Let me do one thing. I'll not run the Docker file now. I'll just say Docker pull Docker image pull Ubuntu 14.0. I'm just pulling this image, sir. Okay, I'm just pulling this image. Now you just see what happens. Now I'm just pulling this image, sir. Okay. Now what is happening that if you come here, you could see that you are able to pull the image, and the image tag is 14.0, 197 MB, and this is the image ID. Just note it down, these things. Now I'll go back to here. Now what I will do, I have a Docker image, Docker file. In this Docker file, I'm not doing anything. I'm just doing a from. Okay. Now let me see what will happen. Now I'll say that I want to build this Docker file. I'll use a command Docker image build. You have to give the tags or something. Suppose like my image, and you have to give some version. And here you have to give dot. Why you are giving dot? Because like in your present working directory, there are many files might be there. Apart from this Docker file, there may be many files should be there, right? Whenever the Docker want to build that image, it'll always checks for this file itself. It always checks for this file name. We're starting with the capital D, and rest all should be small. You need not to mention this like this actually. It's not required. You can even mention like this also. But it is not required because Docker is so clever, it will understand, it will try to search for this file name. So I'm placing dot. Dot means in my present directory, search for the file name of Docker file and build it. When you do a build it, see here what it is doing. See, it has built it. It is using the from Ubuntu and it has built it. Now you come back here. Now you could see that you have created one image of the Ubuntu itself with the name my image, and you have given that as a tag. But if you see it right, what it is doing, the image ID is same as this base image, right? See, 13B655648 and the same size, right? It means that what the Docker file is doing, Docker is not again pulling the everything. It is not pulling. Already there is some image which is already there in the Docker image cache. It is just pulling only the tag, only you are giving a new name. That's all. It means that here what is happening that it is only you're giving only the tag name, but the image ID is same. Okay, that is good. Now what I will do, one thing. This understood, sir? Docker image build -t. So to build a Docker image, you need to execute the command okay. Now what is happening? Okay, Rajesh, I'll do one thing. I'll open the Docker file. Okay. After this, Rajesh, what I'm doing, you know, let me do one thing. Let me touch something abc.txt. I'm just okay. Just I'm creating a file where you're creating under the same image itself you're creating. Now before that, sir, what I will do now, Docker image ls. You're having two images. One is a image which you put, one which you created with the name my image with the help of a Docker file. Now if you do a Docker image, what is it? There's a command with the history command, and you specify this image name. You can do. Sorry, I think I have to do the ID. Sorry, same thing. Sorry, I have to do the ID. Sir. Now you could see that history command will tell you what is this image contains. See, this image these are the contents of the image. What it is basically doing, it is just running on CMD server. Before that, it will try to run systems AD. It is doing some echo and all. Blah blah. It is doing many other stuffs. These are the nothing but these are the contents of this image. Sir. If suppose somebody asks you how you actually inspect an image ID, what this image actually contains, you have to use the history command. Sir. This is one of the interview questions they're asking. Okay, that is a Docker image history and specify the image ID. Right now, you could see that these are the images which these are things which has. Okay, now I don't think I have my Docker file. Now, apart from this image, I'm also creating one file actually. touch abc.txt. Now you see, now I'm going to build this image, same image. What will happen? You see. Now say Docker image, same command, pyld build. Okay, you have to use -t. What is it? My image. I will be giving the version as 2. One I have already given. I will use the tag 2 here. Okay, I'm giving the tag as 2. And what is it? I'll give dot. What happened? Unknown function. Oh, I'm sorry. I have to use the run command, right? Sorry. So now you could see that. Now, if you watch it carefully, sir, what it is doing, right? Already the image is there with this name, right? 13b8. It is not actually pulling it. Already there's an image actually. It is using that image. Now what is happening is that actually in that image, actually it is actually touching a file. It is creating a file. Okay, it is creating a file. To do it actually, it is actually creating a container. Once it creates a container, it will run the touch command onto this running container, and that container will get removed later as an intermediate container, and it will create an image. After that, there is no more instructions are there. A new image will be created with this name. Now you could see, if you see here, go back to the other terminal, you could see one more image with the name my image with the tag 2. Now you could see that this is the image ID, sir. Now can you see out here the same, right? Whatever it's there, this image ID. Later a tag was given to this image with the name of my image :2. Right? Now see what is happening here is actually, now if you understand it carefully, how things are happening is how Docker is actually building an image for by using a Dockerfile is, first it will use the from instruction. For this from instruction, what it will do now, it will try to, it will for how it will happen is actually, sir, in the Docker file, you are having a from instruction, and you say Ubuntu 14.04 like this. Now what it will do, right? While running it, what Docker will do? Docker will create a container, because it has to run this instruction, right? How it can run this instruction, sir? It will create a container. What that container requires? The containers requires is Ubuntu 0.04. So what the container thinks are okay, the container thinks that okay, this Ubuntu 14.404 from. So to do this instruction, what it is doing, it is trying to create with a container with some name ABC, with the name ABC. And what it will do, that container, what it will do, it will try to put the image from hub.docker.com. Do that, and then what is happening that for this entire process, it has to create an image. Actually, it will create an image. Actually. But already this image is already it is created. Okay, already an image is created. Later, what is happening that it will remove the container. Okay, so it is creating one image. That's what we could see here. You could see that actually. Could see that it is not creating it. Already this image is already there. It is not. It need not to build a new image. Already that image is there. In the what happened? It is there in the image cache. It is there. Then what is happening? It is running a touch ABC. So the next instruction in the Docker file is touch run touch ABC. So to perform this action, it has to create a container. What it does, it is going to create a temporary container. Earlier, what happened? A temporary container ABC was created. Similarly, a temporary container EFG will be created. What it will do, it will try to create a file called abc.txt. Where it will create in the same image itself. It will be created in the same image itself actually. But what happened? It will be having a reference to this previous image. Now what is happening that after doing it, what it will do, right? It will create a new image actually, one more image it will create. After one more image created, it will remove the container EFG. So a temporary EFG container was created to create a new image. That new image will have a new file along with the image known as abc.txt, and finally it will remove it. Same thing you could see here. What it is doing to run it actually, it uses some container. This is a container ID. And then after it successfully done created a file, it is removing this container ID E36, and then a new image with this name is created. And after that, what after that what we have in Dockerfile? Nothing is there, sir. Only these are two instructions, sir. Oh, after running this two instruction, whatever the image it has created, oh, that is the final image, sir. And that image, what Docker is doing, it is giving a tag for this. Now that's the reason. If you say Docker image ls, you could see that this is, now you could see that actually the image ID has changed, because here what happened, the both images were same. Even for my image one, tag one, or the version one, the same image ID was there, because in your Docker file you are only using this image 14.04, nothing then. After that, what you're doing, you're trying to create one new extra file ABC. For that, it created a separate image ID. Now you do a Docker image history and specify the image. Now you will make the difference. You will understand the difference. Now you could see that this is the base image, sir. This has everything. See, it is using this reference of this base image. See, it is using this reference of base image. On top of this, you are only creating only one file, sir. Only one file inside that image, and for that, a separate new image has been given. Now let me run that. Now, see, Docker image ls. Okay, good, that we will run. Now we have this image. Can we run this image? I want to see that abc.txt file. No problem, sir. Docker. What is it? Container run -ip -name my image. Okay, and then you give this image my image colon. So you're running inside a container. You will say ls. Can you see your file abc.txt, sir? Right? You could able to see your file here, right? Good. Now I'll exit out from here. Docker container ls. I could see that nothing is there. I mean, you have killed it. Now what is happening that you have a Docker file. Now what will do? You'll say Rajesh, okay, fine. I'll run number run touch abc 1.txt. Same thing. Docker image image build -p. Okay, my image. What is the version? You 3, right? See what it is doing. It is not pulling anything. You could see that for running the second one, it is not creating it. It is using in the from the cache itself, because already we have this image, sir. Already we have an image which has even that touch abc file is there. Oh, I need to only create a intermediate container to only to create a new image. Now if you do a Docker container, now you could come here. Now you could see that one more image has been created. This is the image ID. Now if I do a Docker image history, sir, this has two responses, right, sir? This is the basis, sir. Actually, very basic. I have just started the Docker file, sir. I hope you understood, right? We are giving a different version just to make sure that actually the same image name I'm giving with the versions. I'm just differentiating between one image to other image, because you have to give the tag here. The -t means it's a tag here. Clear, sir? So I hope till here you got it. Okay, you understood the concept here, and I think we will stop the sessions today. Tomorrow we'll continue with the Docker file again. A lot of commands are there. There are a lot of things to play with the Docker file, and a lot of interesting things are there in learning Docker. And then we will get into a Docker compose. Actually. Okay.
Yes,
You might be having you might be having several doubts now as of now, but slowly tomorrow, as and when we progress, right, a lot of other things, doubts will be get automatically get cleared. So you need not to worry.
Yes, sir.
You,
Okay.
you practice till here, it is sufficient. Till now, it is sufficient. Okay, sir.
Yeah, sir. Thank you, sir. Thank you all.
Thank you, Rajesh bhai.
Yeah,
Thanks.
I think
Thank
some
you
of you,
all.
one of you can stop the session so that we'll get the recording.